Hello everybody, I wanted to talk about SelectionSort. We started this in class. It is often hard for me to teach something and code from scratch in class at the same time, so I'm not going to waste your time by coding this, but I do want to show you what I did, because as soon as I got out of class I coded this and I wanted I even had some fun with it and added some graphical quality to it, and I'll talk about that as well. So this video will take a little time, but I just want to kind of walk through how we coded it. So in this case, this is the main method. We've established an initial array of size 8, and then I actually populated that array with random values. And this is the random generator. I believe we talked about this in class, but this is going to give us a random value between 1 and 100. And then I just print that array, and then I perform the selection sort, and I print the array again. We'll talk about this print array function that I built in a second. I just wanted to visually show which part of the array is sorted and which part of the array is not. So that's why we have two pass parameters, and I'll talk about what that does, but that's not relevant to a function you're going to be doing in class at all. It's just me playing with Java. This is the selection sort itself. These are the comments that basically talk about what we're doing. We're finding the index of the minimum element in the unsorted portion of the array, and then we're swapping the element with the minimum element found. And basically we're swapping that, and we'll have a sorted portion of the array in the front, and then the rest of the array still unsorted. For the print job, I'll kind of show you what we're doing. Another thing I do want to mention to you is this is what I want the comments to look like when you're doing projects in class. I want to see the pseudocode or the comments of what you're trying to do for line comments in front of various parts of your array, and then I want to see various parts of your code. Sorry, and then when you have a public method, I want it to be Java docked. So you're gonna talk about what the method is gonna do. You're gonna talk about what parameter you're passing in. In this case, it's the array to be sorted. You're going to talk about any kind of returns you're getting back. So if something's being returned, you're going to talk about that as well. In this case, we're not returning anything as void, so no necessary things here. In this case, this is a private method, so I don't need this to be Java docked at all. I just want a block comment. Same thing. I want to talk about the parameters that we're sending in to explain that code. But what we're doing here is I want to show what is unsorted and what is sorted. So I just use these escape sequences to push in colors into the console. I want to see the unsorted part with a red color and the sorted part with a green color. And basically what's happening is it prints the array just like we did in class with a comma between the elements until it gets to the last one, and it doesn't print with a comma separator. In our case though, we wanted to go ahead, if we don't need any kind of highlighting, we pass in -1, so it just prints all the elements out the same way. If we want to highlight some of it, we pass in the screen part, and the screen part is just highlighting what is already sorted, and the red is what's unsorted. All right, and of course I created a swap method, but I'm not using that swap method at all. I've decided to just swap within the other elements. So that's what we're seeing here, and I want to show you guys how this looks. And let's run this program. So I'm going to go ahead and just say Java selection sort. And you can see what happens here. In the first pass, we have 1. So the original array looked like this, right? And so in the first pass, 1 was swapped with 16. You can see that 1 becomes a sorted part of the array. In the second pass, or swap 2, see 5 is already in the right place. We don't have a swap there, but we do need to swap in the third pass, and so we swap there with with 16 and 26. And then you can see which ones get swapped as we go on until we get to the last part. No swap is needed. This is the sorted array. All right, so what you're seeing is an 8-element array, and this is n squared on the algorithmic efficiency. But what you're actually seeing when it says 28 passes, I'm going to jump in here and show you what we're actually looking at. What you're looking at is the first time we pass through this array, right? We set the original index as min. We're going to swap there if we find anything smaller. And so you're actually going through 7. elements of the array, the very last part. You're going to have 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. That's why you have 28 passes of the array. But of course, O to the n is 8 times 8. That would be 64. I'm sorry, O to the n squared is 64. O to the n would be 8. Technically, the way I built this algorithm, it's going to run 28 times before it terminates. Um, we push that down to O n squared because that's how big O notation works. And I'll spend more time talking about that shortly. But this is an O n squared algorithm. It does not run at O n times. So it's not running just 8 times. It's running at O n squared times. So it's larger than, it takes more durations than just the number of elements in the array to run. Okay, so that's the selection sort. I can modify what I've output, but this is what you want to look at right now. So we're going to stop the recording here.